Good morning. We are now studying the De Morgan's theorems. De Morgan is a great mathematician who contributed two important theorems of Boolean algebra. Theorem 1 states complement of AR, BR, CR, etc. will be equal to complement of A and complement of B and complement of C and so on. It can be read as the complement of R sums, the complement of R sum equals the AND product complements. And we have one more theorem, second theorem, the complement of A and B and C and so on will be equal to complement of A or complement of B or complement of C or so on. In the sense, the complement of AND product equals the R sum complements. The complement of any Boolean expression or a part of it can be found out by making use of these two theorems. And the following two steps are used to form a complement. And these are the two steps that we use in order to form a complement. The dot and the plus, in the sense the and or symbols are interchanged. Dot and plus are interchanged. So you can see both in theorem 1 and 2, the dot and the plus symbols have been interchanged. And each term in the expression is complementary. You can see here in both the theorems, LHS is the complement of whole term, whereas the RHS is such that each term is individually complemented. The symbols have been interchanged, and each term is complemented on the RHS. Whereas on the LHS, the whole term is complemented. So these are the two steps to be followed while applying Boolean expression to any part of the expression. While applying these two theorems, these two steps have to be followed. Now, we have an example. So let us consider theorem 1. Complement of A or B is equal to complement A and complement B. The symbols have been interchanged and the complements also. The left hand side of the above equation is the output of NOR gate having inputs A and B, whereas the RHS is the result of inverting A and B individually and then applying them as the inputs to the AND gate. Hence AND gate with inverters on each of its inputs is equivalent to NOR gate. Similarly, if we apply theorem 2, let us consider complement of A and B that will be equal to complement A or complement B. Left hand side is the output of NAND gate having two inputs A and B. Under the RHS, we have complemented A and B, and the complements of A and B are fed to the inputs of OR gate, and the output is similar to the NAND gate output. So you can see here we have a truth table. Two inputs A and B are there, having inputs 0, 0, 0, 1, 1, 0, 1, 1, 4 different cases. A and B are individually complemented. Complement of A, complement of B, and this is the output of OR gate of having inputs A and B. This is the output of AND gate for the inputs A and B. Now the output of OR gate is complemented over here. This is the complement of the output of OR gate, and this is the complement of output of AND gate. Complement of output of AND gate. Similarly, these two inputs are also applied to the AND gate. These two inputs are also applied to the AND gate, which gives this, right? Similarly, complement of A and complement of B are applied to the AND gate, which gives an output like this. Now, according to this, you can observe these two are similar. These two are similar, right? Similarly, these two are also similar. You can see here, these two are also similar. These two are similar, and these two are similar. And this is about the De Morgan's theorem. Now, standard forms of Boolean expressions. To implement a Boolean function with less number of gates, we have to minimize the literals and the number of terms. Usually, literals or terms are arranged in one of the two standard forms. And the standard form is the sum of product form. We have two standard forms, and one among which is the sum of product form. The sum term is any group of literals that are ORed together, like A or B or C or X or Y, etc. A product term is any group of literals that are ANDed together, such as A, B, C, X, Y, and so on. This is the sum of sum form, and this is the product form. And these examples represents the sum of product form. Sum of product. These are the products. ABC is one group of product. A complement B complement C. A complement B complement C is another group of product form, and they are summed together again, and so it is called sum of product form. Similarly, XY is one product. X complement Y, Z is another product group. YZ is the third product group. They are summed again, and therefore it is called sum of product form, and etc. We have one more form, which is product of sum form. In the sense, we initially take the sums, and their sums will be ANDed, and therefore the name product of sum form. Examples: AB is one sum group, complement B or C is another sum group, and they are ANDed, or their product is taken. Similarly, A or complement B or C is one group, B or complement C or D is the second group, they are ANDed. They are ANDed, or their sums are taken as the product. And this is another form to minimize the number of literals or the number of terms. We have these two different forms, sum of product form and product of sum form. Thank you.